Hi there, 8th graders. Lesson 49, solving rate problems with proportions and equations. Alright, objectives. Solve rate problems by writing and solving proportions. Solve rate problems by writing an equation using the unit rate. At this point, you can do your power up. Then I'm going to keep moving on. If you're not going to do a power up, just move on with me. Alright, rate. Rate is a ratio of two measures. In this case, we have 100 miles over 1 hour. So you'd be going 50 miles per hour. The next one, you have 100 miles per 2 hours. And 150 miles over 3 hours and 200 miles over 4 hours. Are these ratios equivalent? Are they proportional? Well, do you think they would reduce down to the same thing? I believe they would. You should end up getting 50 miles per hour if you reduce them down. Okay? So I would say yes to that. Are they proportional? Well, I'd say you're multiplying the top and the bottom by the same thing. So yes, I'd say they're also proportional. All right. If 6 books weigh 15 pounds, how much does 20 books weigh? Okay? So I created this little chart like we have been using. Obviously we don't have a total. So I'm going to put books over weight. Actually, let's go the other way. Because then I can find out the weight per book is. So I'm going to go weight over books. Because now I can find out what each book weighs by dividing. So this is 15 pounds over 6. And this is going to be 20 over, we don't know. Alright, so we should be able to cross multiply here. So we'd have 15 equals 15 over 6 equals 20 over x. We get 15x equals 1200 divided by 15 divided by 15. X equals, well, so we want to know, oh, I put that wrong. That should be here. My bad. It shouldn't be books. How many books? How much does 20 books? Yes. So, I did that wrong. Okay, so we are going to have that, which multiply that together, you're going to get 300 equals 6x when we cross multiply. Alright, divide by 6, x equals 50. So 20 books would weigh 50 pounds. Okay? And that is our answer. Alright. On example 2, if 6 books weighed 15 pounds, what is its unit rate? What is the weight of 20 books? Write an equation that shows how to find the weight W of books, knowing the number N of books. Okay. So, we want to find a ratio. Well, a ratio is going to be, we kind of created one, we just never simplified down. You remember we had 15 pounds over 6 books. When we divide this, we'll find out which each book weighs. So, for one book, we would take 15 divided by 6, and we get 2.5 pounds Or rate, yep, rate. Okay, what is the weight of 20 bucks? Well, we found that out earlier. It was 50 pounds. We need to write an equation. Well, alright. Every time this is going to change, and this is going back to the proportional equations or functions and stuff, we have to create something like that. So, I don't know how many books I have, right? So I'm going to put n. But n times the weight, alright, n times the unit rate, so times the rate equals w. Okay? My rate in this case is 2.5 pounds per book. Well, this is going to be my pounds, this is going to be my number of books. I multiply by this, like you could sub in 20, and you would get 50. So there is my weight, there is my rate, weight for 20 of them, equation to find any number of books possible. Julio is riding a bike in a 50-kilometer bike race. He passes the 15-kilometer mark in 27 minutes. If Julio continues to ride at the same rate, what will be his time for the whole race? Okay? Once again, we have 15. Let's go 27. Or 27. Actually, I think I'm going to say kilometers. Because we always think, how far could we go? Over minutes. Okay? So, alright, and we want to go 50. In how many minutes? We don't know. Okay, so what I do here, once again, is cross multiply. You have 15x equals 27 times 5. Okay? Or 50, I guess, would be 1,350. Divide by 15, divide by 15. X is going to equal 90. So if his pace keeps the same, obviously we know that more than likely his pace would drop off, we would like to think, unless he's really well conditioned, and there's a lot of variables in it, but he should be able to do this in 90 minutes. Okay? In example 3, what is Julio's rate in kilometers per minute? Write an equation that relates Julio's distance to the time traveled. Alright, so what I would do, it's not probably the easiest thing, but I would take this divided by that. So I'm going to take 15 divided by 27, and I'm going to get that he's going about 0.5. Let's go 556 kilometers per 1 minute. Okay, so there's my rate. Okay? So if I wanted to know his distance, d, I would have to take it times my rate, which is 0.556, times the amount of kilometers Julio went. So there would be my equation for that one. Obviously I had to round there a little bit, which might be a problem. You might have to leave it in regular form to get a more accurate answer, but that would get you a ballpark average. Oh, or the other way, like I said, this would just get you a ballpark, would be the fact that you would have to leave it in a fraction form. Can we reduce this fraction? Well, we can take a 3/8, so we get 5/9. So the other way you could write this is also 5/9 times your kilometers you travel. That'll give you a more accurate answer. That'll make it so you have no error. But you have a fraction in there, which some people do not like. Okay? 3 tickets cost $20.25. How much would 7 tickets cost? What is the unit cost? Okay. The nice thing about this type of problems, there's 2 things I really like about it. A, we're setting up proportions and basically solving them that way. And B, you could just find the unit rate and then multiply it by 7 if you want. So you have $20.25, and that was 3 tickets. Okay? Equals something over 7. Okay? So you would take 25 cents times 7, which would get you 141.75 equals 3x. Divide by 3, we get x equals 47.25 is what you'd have to pay. Now, once again, we have to find the unit rate, so you take this divided by that. And it's $6.75 per ticket. Per one ticket. So there's your rate. Okay. Go ahead and do your practice set, all of it. Like I said, if you miss class, come in and get help from me on the practice set if needed, or if you have any questions and want to make sure you're doing it correctly. Obviously, there's your homework. If you got questions on your homework, come and ask me anyway. Because maybe you need help on a different situation, or different section, where now this is what we worked on today, and I want to make sure you understand that for sure, so you're not confused later when you have it as a review problem.